Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I will be guiding you through this problem today. What 5 types of R group interactions contribute to the overall tertiary structure of a protein? So there are 5 different types of interactions, 4 of which are not covalent, and 1 is covalent. It's an actual bond, a covalent bond made between 2 R groups. So the first type we want to talk about is hydrophobic. A hydrophobic interaction. Now, a hydrophobic interaction occurs between 2 nonpolar, or 2 or more nonpolar R groups. It occurs between nonpolar R groups. Hydrophobic essentially means water-fearing. So the water-fearing groups will actually find each other on a protein, interact with each other, and will cause the protein to turn or to fold in order to avoid interacting with water because they are afraid of it, phobic. They have a phobia of water. Hydrophilic. Hydrophilic interactions are interactions between R groups that love the water, and they will actually turn themselves to face the water or to interact with water. So it occurs between polar R groups and water. So if you will, consider that some polar R groups will actually fold away from the protein into the water environment that they're sitting in and interact and hang out with the water molecules. That will also cause the protein to fold and to turn onto itself. That's a hydrophilic interaction. Salt bridges. Now, a salt bridge is an ionic bond between two charged R groups. That generally occurs between acidic and basic ones. So what will happen is you'll have one acidic side chain over here, a basic side chain over here. They'll react. One will protonate the other. You'll have a conjugate base, conjugate acid interaction, and they will be attracted to each other. So basically you'll have a cation and an anion being attracted ionically to one another. That's a salt bridge. Hydrogen bonding. Hydrogen bonding occurs between R groups that have either NH or OH side chains in the side chain. Also known as the R group. And finally, disulfide bonds. Disulfide bonds are the only covalent bond and it is always sulfur to sulfur. That is a disulfide bond. Okay? Now these little brackets aren't part of the bond. I'm just trying to emphasize it to you. Okay? So that's your disulfide bond there. So hydrophobic occurs between nonpolar R groups. R groups that have carbon and hydrogen. Hydrophilic occurs between polar R groups and water. Basically, the protein will turn to allow those side chains to face the aqueous environment of typically where you find enzymes or proteins. Salt bridges are ionic bonds between two charged R groups. Hydrogen bonding, R groups that have NH or OH in the side chain. So those R groups will interact. They will hydrogen bond with each other. Disulfide bonds are covalent bonds, sulfur to sulfur, single bond. Okay? All right, now, I know that's a lot. My advice is to either do one of two things or both. Watch the video again and read it in your textbook. Your textbook spells this out very nicely. Don't sit back on this. Don't think that it's not important, because all these interactions are important. Okay? I know there's a lot here. I know it seems like an insurmountable goal, but you can do this. Just make sure you're ready to do it on an exam. And just so we're clear, that's a disulfide bond. I put these little brackets in as embellishments. Okay? That's a disulfide bond. All right, guys? Now with that, I wish you good luck and good chemistry.